Hello, astronomy. Welcome to our first video lecture for Unit 2, The Birth of Modern Astronomy. So this unit is divided into 3 sections. The first 2 sections are a pretty deep dive into some history of astronomy. Mainly, we're going to discuss some very important scientists that leads us to Unit 3, which is the layout of the solar system. So the first 2 units are sort of a history of how we got to Unit 3. How we came to understand the actual organization of the solar system. So let's just begin with this individual here. So this is Aristotle. You've heard of him before. Aristotle was a very famous Greek scientist, philosopher. The Greeks were sort of known for being really big advocates of reason and the power of the mind, that you can basically figure out any problem if you just think about it long enough. And Aristotle is sort of a good example of this. He founded a very famous school. He was, one who taught Alexander the Great. The Greeks were not really that big on actually doing experiments and actually like measuring and observing things to figure out how the natural world actually works. They were big on using your brain, using your powers of reason to figure things out. And that's, that's not anything to demean. The power of reason is, a very important thing to advocate for. Aristotle, for example, taught that the Earth was a sphere, which is true. The Greeks knew the Earth was not flat, but his reasoning was, or sort of the Greek reasoning was, that the sphere is a perfect shape, and so therefore the Earth must be a sphere. Now, Earth isn't a perfect sphere; it actually bulges at the middle a little bit. So they were on the right track. The reasoning wasn't exactly accurate, but it got them to more or less the right conclusion. Many Greek ideas, things like the atom, were first sort of theorized by the Greeks, just using the powers of reason. Now, Aristotle also taught that the Earth was stationary, and that the planets and the sun and the stars all revolve around the Earth. Of course, his reasoning would be that you can't feel the Earth move; it had to be moving very, very fast, and you can't feel it move. Of course, we know that the atmosphere is moving with the Earth. So for you to feel the Earth's movement, you'd have to feel the air, and the air is moving with the Earth. There was an ancient Greek scientist named Aristarchus who did propose that the sun was the center of the solar system. The planets and the Earth moved around the sun, but you really couldn't prove it. And so his ideas were somewhat lost to history. They weren't lost to history, but they weren't really that popular in ancient Greek times. They weren't really advocated for. Aristotle's ideas were sort of like the gold standard, and he had lots of ideas that were great. But the motion of heavenly bodies was one that he definitely got wrong. So Ptolemy is the next individual. Ptolemy was a scientist in ancient Roman times. We've discussed Ptolemy before. Ptolemy wrote some very, very famous works, which were preserved by Islamic astronomers. Ptolemy was the guy who, Ptolemy was making models of the heavens to help predict where things would be in the sky. And Ptolemy was the guy, this is a Ptolemaic model of the solar system. You can see the Earth in the center, then the moon, Mercury, Venus, then the sun, Mars, Jupiter, Saturn. So Ptolemy had the idea of the nested spheres, where like the stars, for instance, are in sort of the outermost nested sphere. And it's those crystal spheres that are turning around the Earth. Like Mars has a sphere, Jupiter has a sphere. He was also the guy who used the idea of epicycles to explain retrograde motion. I know back in Unit 1, we discussed retrograde motion. And I know that I showed you this little video. I'm not going to show it again. But retrograde motion was the idea, how Mars is throughout the night. You can see Mars at some point just come up loop backwards. If you forgot, go back and look at the videos for Unit 1. But Ptolemy was the guy who proposed the idea of epicycles, and this little animation kind of shows that pretty accurately, where you can see the orbit of Mars is always going counterclockwise, but there's sort of this nested thing called an epicycle in Mars's nested sphere, and Mars is moving counterclockwise in the epicycle. So there are times, I'll play it one more time, when Mars seems to go backwards in the sky relative to its motion on previous nights. Ptolemy, very famous guy. And, once we skip ahead to like the Middle Ages and the early Renaissance, Ptolemy's views were seen as almost biblical. Like if you go against Ptolemy, you're going against the church. And I'm being a little oversimple when I say that, but in some ways I'm kind of not. Like Ptolemy was the foundation of how the heavens works. And Ptolemy's models were very good at predicting where things would be in the sky, but they weren't perfect, right? So skip ahead. Nicholas Copernicus was a Polish mathematician, astronomer. He is living in the 1400s and the 1500s. Copernicus, again, he's living in Poland. He's Polish, and he worked as sort of like a local sort of church administrator, church official in the Catholic Church. He worked for sort of like the local cathedral. The church owned lots of lands. He'd be one of the guys that would help keep the books for farmers paying their rent, or collecting whatever needed to be collected for the church. He was a church official. That also gave him a lot of spare time to study the sky. And Copernicus, had no interest in going against the church whatsoever. He worked for the church, but he knew that Ptolemy's models weren't perfect, and they didn't perfectly, or didn't always accurately predict where things would be in the sky. And Copernicus figures out, of course, he wasn't the first guy to figure this out, but he was one of the most noteworthy, that if you put the sun at the center of the solar system and have the planets going around the sun, number one, you don't need epicycles, so it makes the model way simpler, but it's also more accurate in predicting where things would be. People who were sailors who were very good at navigating things in the sky sort of knew that the Earth-centered model, the geocentric model, really didn't always work, and that a heliocentric model actually worked better at predicting where things would be in the sky. So that this wasn't a sort of a new idea. It wasn't really put down into words well with lots of evidence until Copernicus comes around. So Copernicus published this book, very, very, very famous, very controversial, called On the Revolution of the Celestial Spheres. And it basically lays out his evidence for a heliocentric model of the solar system. He had sort of run this by some of his church friends before, and they, he knew this was going to be a blasphemy. When he publishes this, he's basically on his deathbed. There's an old story that when the first copy of his book arrives at his house, he's literally on his deathbed. I'm not sure if that's true, but by the time this becomes popularized, by the time it becomes a controversy, he's dead. So he can't be persecuted for it. The book is obviously banned. It's not taught because it goes against church teachings. Quick sort of aside, this is a Copernican model of the solar system, and if you notice, the sun's the center, Mercury, Venus, there's Earth, there's the moon, Mars, Jupiter, Saturn, then there are the stars. A couple of things are wrong with this. Number one, he has the orbits as circles, and his predictions for where things would be also weren't completely accurate. There were issues with it that he couldn't explain. Later, Johannes Kepler comes along, and Kepler's the guy that figures out that the orbits are elliptical, not circular. If you just change this to where the orbits are ellipses, it's accurate, right? Copernicus didn't know that, obviously. Another problem with it, of course, the relative distances are way off. The outer planets are way further away than this shows. But this says what, stellarum fixatum or whatever, immobilis. So the stellarum fixorum, I can't pronounce that, immobilis. Basically, it's that sort of outer nested sphere, although he dropped nested sphere part. Immobilis because the stars don't move relative to one another, and they should be way further out. The stars are way further out than the planets are, and people at the time didn't quite realize that. Part of the problem with a sun-centered model was if the Earth is what's moving, which it is, then there should be times when you're closer to a certain star than others. Like if the Earth is here versus over here, you're further or closer to certain stars, right? I mean, you are, but the stars don't get brighter or dimmer in the sky. They're the same brightness. And Copernicus couldn't explain why that was. If you're closer to it, it should be brighter. Of course, the issue is the stars are so much further away than being the minuscule amount Earth's closer to it in its orbit doesn't make a difference because the stars are hundreds, thousands, millions of light years away. So whether the Earth is here in its orbit or here, you're not that much closer to make a difference. But Copernicus's model is not perfect, but it puts the sun in the right place more or less. Quick aside, so when Copernicus dies, he dies not the most popular person, like he's a bit of a controversial figure. So he's buried, you know how in Europe people are buried like in the floor of cathedrals. He's buried in the floor of the cathedral where he worked in Poland. But he's sort of hastily buried, and he's not given a really good marker for where he's buried. There's sort of like an oral history that he's buried by that thing in the wall right there. Just dig right there, you'll find him in that whatever, they would point to a spot. And in the early 2000s, not that long ago, they actually dug him up where he was supposed to be, and found his skull and did a facial reconstruction. And this is the facial reconstruction. So this is Copernicus. I want to say this might be a self-portrait. I'm not sure about that, but that's a portrait of him. And like, look at his nose, look at his face. He dies, I think he's in his 70s. He lives longer than most people do. It looks pretty like young Copernicus, old Copernicus, looks like the same guy. Copernicus, when he was younger, had an injury to his nose where his nose was pretty badly broken. He kind of has a little bulge right there. And the skull had an issue with the nose. Plus, he had a scar somewhere above an eyebrow or his forehead, and you could tell by the skull that he had the scar. Anyway, skipping ahead, they dug him up, did the facial reconstruction, and they found modern day Copernicus's into DNA testing, and it matched. So that was actually Copernicus, and he was given a proper interment. This is his marker in the cathedral in Poland, and it's kind of a cool little marker. He's right here. You can see the sun and the planets. The little hole in the ground. You can look down to where his remains are. So he has a proper burial now. Only took a couple centuries to give him what he was due. Anyway, so that's Copernicus, 1500s. Okay, so skip ahead to Galileo. Galileo is the 15 into the 1600s. So Galileo, obviously very, very famous guy. He's going to get himself into a lot of trouble, which we're going to see here in a minute. Galileo was Italian. Devout Catholic dude, had no interest in going against the church. Galileo was a pretty famous guy. If you look here, he's holding what looks like a telescope. So Galileo does not invent the telescope. All right, if people say he did, they're incorrect. The telescope was invented. There's not one person. In the centuries prior to Galileo, the Dutch were really good at making eyeglasses. And they had figured out that if you put lenses like in sequence, you can like magnify things, make things that are further away seem closer. And the idea of like a spyglass, like what a sailor would use to look at things out at sea, or if you're looking at enemy ships coming into your harbor, you use the spyglass to look. That already existed. Galileo was the first guy to take that idea and point it to the stars. So he sort of invents the telescope for astronomy because he's the first guy to really do that. And grinding lenses down to where I'm wearing glasses here, to where they're like sort of uniform in the curvature and you can see through them well. That's really it's an art and a science. And he was the first guy really to get really good lenses ground. He wasn't doing the grinding himself, and put them in sequence, the right distance and the right focal points to look at things in the sky. Galileo also, he wasn't afraid of controversy. He wasn't afraid to tick somebody off. He had a daughter who was a nun, and there was a book called Galileo's Daughter. You should read it if you ever have time. It's a fascinating book. So he has a daughter. Oh, by the way, Galileo was never married. So he has a daughter who's obviously legitimate. And I guess he sent her to the convent. I'm not sure, but she was a nun. She lived of course, he's outside of Florence, right, in Italy. He lives in a convent in Italy. And they write letters back and forth for decades. And the letters that she wrote to him still survive. The ones he wrote to her have been lost. But the book, Galileo's Daughter, sort of chronicles his relationship with her. It's really quite a sweet book. Like there'll be a letter she sends to him saying, like, I have your shirts laundered, come and get them. Like they're ready, just come pick them up. It's very like day-to-day, just, the business of simpletons. But she does advise him sometimes about ways to not get himself in trouble. But anyway, he wasn't afraid of controversy. So Galileo points his telescope at the stars and at the sun, which is obviously a very bad idea. Galileo goes mostly blind in his old age, probably because he looked at the sun through a telescope too much, which you should not do. But some things he discovered. So he discovers that the sun has spots. We call them sunspots, and that those spots can move, which means the sun rotates. The church at the time, taught that the heavens were created by God and they're perfect. So if they're perfect, they cannot change. Because if it's perfect, why would it change? So the idea that the sun has spots that move means it's not perfect. He discovered that Jupiter has 4 large moons. Ganymede, Europa, Callisto, and Io are called the Galilean moons. We'll talk about them in a later unit. Jupiter has dozens of moons, but the 4 biggest, which the biggest moon in our solar system is called Ganymede. It's a moon of Jupiter. It's bigger than Mercury. It's bigger than Pluto. If it were orbiting the sun by itself, it'd be a planet. But the 4 largest moons are called the Galilean moons because he discovered them. If you look at this picture, this is a picture from his writings. This is Jupiter. And you can see the sort of asterisk looking things. There's 3, there's the 4. This is, dates, and he's pointing out where they are in the sky. And by the way, with really good binoculars, you can see Jupiter's moons, or the 4 biggest moons. They're telescope, you can see them very, very easily. But look what's going on. The moons are in different positions, which means the moons move, which means the moons are moving around Jupiter, right? Of course, the church was teaching, everyone was teaching that everything moves around the Earth. So this just shows that the moons of Jupiter are moving around Jupiter, which goes around the Earth, but the Earth isn't the center of these moons' orbits, right? Okay, Venus experiences phases like the moon. This might be the biggest deal of all for Galileo's discoveries. So Venus goes through phases. You can see a crescent, you can see a quarter, you can see a gibbous, you can see a full Venus. If you look at Venus through a telescope, you can totally see that Venus goes through phases. A full set of phases like the moon. Now, this is very consequential, all right? Okay, so take a minute and just look at this diagram while I'm talking. So Venus goes through a full set of phases. You can have a full Venus. If Earth is the center of the solar system and Venus goes around the Earth with the sun, you can never have a full Venus. If you look at this diagram, first off, one thing I should point out, Venus is always near the sun in the sky. You see Venus at sunrise or sunset near the sun. You never see Venus like at midnight. Right? It's always with the sun. So for an Earth-centered model, Venus is going around the Earth sort of along with the sun. And if you look at this, the lit side of Venus always points away from the sun. So you'd have like a sliver of Venus, a crescent Venus. To have a full Venus, you'd have to have like Earth in the middle and the sun and Venus on opposite sides of one another, which can't happen if Earth is the center of the solar system. So with this model, you never see a full Venus, right? Well, we do see a full Venus. So look at this diagram. So this diagram shows a heliocentric model. And so here's the Earth, right? Here's Venus going around the sun. This diagram doesn't show Earth's orbit, but picture Earth's orbit looking kind of like that. Here you'd have a new Venus, which you can have a new Venus. So you have a crescent. If Venus is on the other side of the sun, you'd have a gibbous Venus or a full Venus, right? You'd always see Venus near the sun. If you look at this configuration, it's near the sun here, near the sun here, near the sun here. But Venus can go through a full slate of phases. So probably Galileo's biggest argument for the sun being the center and us going around the sun is because you can see a full Venus, which there's no way you can see a full Venus if this is correct, right? Okay, so skip ahead. So Galileo was already a very famous guy with his telescope invention. He had made some money. He was a famous professor, famous mathematician. And he had talked about his ideas with some of his church official friends, and he had gotten into a little bit of trouble in the past teaching this, and he sort of, you kind of got away with teaching this in this time if you basically were teaching it hypothetical, like if you were teaching this model as a better way to predict the locations of objects, but you weren't teaching that it was true. If you were teaching that it was true, you'd get in trouble. if you were just teaching it as a convenient model for finding things in the sky or navigating on the sea, you could kind of get away with it. And Galileo walked that line decently well until he didn't. So he publishes this text. This is the one that gets him in trouble. It's called Dialogue Concerning the Two Chief World Systems. And basically, it's written as a dialogue. It's almost like a play, although it's not a play. It's written over the course of 4 days of two guys. There's two main characters, and they're debating the two like formats of the solar system. The guy who's advocating for the sun-centered model, it's not Galileo himself. These characters have names, but the guy who's advocating the sun-centered model, the Copernican model, is written as very intelligent. He's written as a Galileo-like character. He's witty, he's funny. The character who argues for the Earth-centered model is written as a simpleton. He's written as not the smartest guy. He's kind of a religious character. It's very tongue-in-cheek, and if you read it from the perspective of the church, it doesn't make the guy arguing for the Earth-centered model kind of comes across as an idiot. But once the church caught wind of this, they were not happy. Galileo had crossed the line. They summoned him to Rome, and he's basically given, there's a trial of sorts. He's basically given a chance to. Oh, I should point out one thing. Previous to Galileo, decades earlier, there was a Italian named Giordano Bruno, who was teaching the sun-centered model, and he was burned at the stake. All right, so this was serious stuff. Like, people were killed for teaching this model. So at the end of his trial, he's basically given the option of either recanting and saying that he was wrong, or basically being killed. And he doesn't basically, he recants. He signs a statement saying that he was wrong, that he doesn't go against church teachings, that he's sorry, and he's allowed to go home. He lives the rest of his life under house arrest. Basically, he can't leave his home. And at this point, he's getting pretty old. Again, he's getting to be decently blind. People come to visit him a lot, and eventually even visitors are banned from visiting Galileo, because visitors come to him from outside of Italy, places where the Catholic Church didn't have dominion, and to learn from him. They realize that's happening, so they basically banned him from having any visitors too. It's also worth noting, teaching that the earth moved was considered blasphemy for a couple reasons. There's a verse in Joshua, in the Old Testament, that's held up as a evidence for an earth-centered model. That basically, it's one of these times when the Israelites are going to the promised land and they're fighting the people who are there. And it's a verse in Joshua where I think they're fighting the Ammonites, maybe. Am I making up the Ammonites? I think they're called the Ammonites. You can Google it. But basically, God makes the sun stop in the sky. The text says that the sun stopped in the sky. And it made the day longer, so that the Israelites could finish slaughtering whoever they were fighting, and they do. But because the verse says the sun stopped in the sky, it doesn't say that the earth stopped rotating. It says the sun stopped in the sky. So that was taken as church teaching to support the idea that that the sun moves around the earth because God stopped the sun moving. The verse doesn't say God stopped the earth from rotating. And they used that verse in Galileo's trial. This wasn't just Galileo, this was a famous verse, to advocate, to provide evidence for the earth-centered model. So Galileo recants, he's allowed to go home. Okay, so we're gonna stop there on that happy note. The church did finally apologize for Galileo's issues. It was Pope John Paul II, so it was in the 1980s. I don't want to be too harsh on the Catholic Church. Protestant churches, Lutherans, Calvinists at the time, all of them were condemning Galileo. All of them were saying he was going against the Bible. He was universally condemned as a heretic by any church at the time. It wasn't just the Catholic Church. His writings are banned. Of course, later they're not banned. they spread throughout Europe anyway. And again, it was in the 80s when the church officially apologizes to Galileo. Okay, so we're going to end part 1 of unit 2 there. I hope that was helpful, and I will see you guys next time.